And I'm Xini Liang from number 2 High School of East China Normal University in China. And today I'm going to present on financial risk modeling, which is the use of formal mathematical and econometric techniques to measure, monitor, and control financial risks. I'll first dive into some specific models used in this field, and then reflect on the significances and limitations of these models in general. So, firstly, let's look at some specific models. The first one is the value at risk, or abbreviated as VAR. This is quite commonly used as a measure of the risk of loss of investment or capital, and it estimates how much a set of investments might lose in a set period of time. So, before any calculations, we need to know that this model is based on historical simulation, where we simulate historical data on asset returns over time. For example, the left image shows the histogram of the distribution of daily returns on 1,387 um, specific daily returns. And we can then convert those data into the cumulative distribution function for daily return, which is also called CDF. To briefly introduce what a CDF is, a CDF of is the probability for a random variable x to take on a value that is uh, less than or equal to a specific number of x. So now let's dive into the calculation involved in this model. The statistics of the value at risk model is PVAR, where the probability of a loss less than VAR, the value is at least P. So let's look at the image on the right. It is a probability density function on the magnitude of loss over a specific time period. And now we can see that there is a point of $175 on the graph that corresponds to the 90% VAR. So this means the probability of a loss less than the VAR value, or 175, is at least 90%. In other words, the risk for us to get a loss that's over $175 is simply 1 minus the 90%, which is 0.1. And this $175 is also called the VAR breach. However, for most of the time, we don't really know what the VAR breach value is. Instead, we want to investigate the VAR at a specific probability. So now let X denote the profit and loss distribution, and Y is the threshold value where the probability for X to exceed Y is alpha. And now we can simply decide the VAR breach value by um, using the 1 minus alpha and finding the corresponding value on the inverse function of the CDF of Y. And so now let's look at another model that is used to determine financial risk, called the extreme value theory, or a branch of statistics dealing with the extreme deviation from the median of probability distributions. So, unlike the VAR model that looks at the probability to have a loss of a specific amount of money, this extreme value theory looks at the probability of loss due to a unpredictable and extreme event. So now let x1 through xn denote a sequence of IID, or independent and identically distributed random variable, with the CDF capitalized F, and the Z is the frequency of the extreme event that we want to measure. So here the probability for all x's to be smaller than z is just equal to the product of the probabilities for each x to be smaller than z. And since the x's follow IID, this probability is fz to the nth power. And now the indicator function in, where um, the odd x's are greater than z, follows the Bernoulli distribution with a trial number of n and a success probability of 1 minus fz to the nth power. And with the calculations and properties of Bernoulli distribution, we can calculate what we want. And now, knowing two famous distributions, models of financial risk, we can reflect on those models in general. So, first of all, these financial risk models are significant because they allow us to analyze and make forecasts of the likely loss, which help us to estimate the amount of capital reserve to maintain and guide purchases and sales of financial assets. It allows us to make the theoretically minimal choices and help stabilize the economy. However, there are some general challenges faced by the models. Most of the models base their calculations on specific statistical distributions, which often has the assumption of IID, but that is not actually the case for many real cases. And also for models like VAR that depend on historical simulations, they often neglect the diminishing predictability of data since time changes things. These problems are often faced by currently seen financial risk models, and I believe by solving these problems, we can get preciser estimations of the risks and further stabilize the economy. And that's the end. Thank you.